Let's keep going on some examples for law of cosines. Here we have angle C. We have side A and side B. We do not have angle A, angle B, or side C. So if we go ahead and plop these down here, we know that A is 14 and B is 12. Now if we had two angles and one side, we could do simple subtraction, find the third angle, and then we could do law of sines, right? Here, however, we don't have the information that is necessary in order to do law of sines because we can't find a complete ratio, right? We need a complete ratio to use law of sines. And as I've said before, you can memorize all the special cases and everything like that. It's better just to, okay, ask yourself, can I make a complete ratio? If you can't, you have to use law of cosines, at least for that first step. Let's go ahead and look for C. So C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Okay, well let's actually see how that works out. All right, we have 14 squared plus 12 squared minus 2 times 12 times 14, and I got those out of order, but it doesn't really matter. Multiplication is commutative. And the cosine of 42. Now, that's what C squared is. So let's go ahead and take the square root of that, and C winds up being approximately 9.503. So 9.503. Now, what would probably be a good idea is let's go ahead and store that in for C. Now I have a complete ratio. And now that I have a complete ratio, I can use it to find either A or B. Now once I find either A or B, simple subtraction will allow me to find the third angle. So let's go ahead and set it up over here. So, and I'm looking for, let's look for angle A. So sine of A, okay, over A is equal to sine of C over C. And so I'm going to get sine A is equal to 14 sine 42 degrees over 9.503, and A is going to be the arcsine of that. So let's go ahead and find that ratio first of all. So 14 times sine of 42, all of that over, and I stored this into C, so I can just put C. And now that's 0.986 basically. That is really close to 1. So I should be expecting my sine to be something really close to 90 degrees. Okay, so let's do the arcsine of that answer, and it winds up being 80.331 degrees. Okay, so if we have, oh sorry, that's here, 80.331 degrees, I simply need to do a little subtraction. B is equal to 180 degrees minus A minus C. And so 180 minus that, and then minus 42, which is angle C, and I'm going to get 57.669 degrees. 57.669 degrees. And I have solved for the entire triangle. And that's not really all that much work, right? It's obviously a little bit easier when you don't have to shuffle any of these things around and actually solve for an angle measurement over here. You simply have to combine all that stuff and then square root it. But, you know, this one was pretty easy. Not all of them are. All right, let's go ahead and take a look at this. Now, I am given two sides and the included angle. Now, if I were going for the area, I'd be golden, but I'm not. I'm actually trying to solve the triangle. So what I need to do is I need to, I don't have a complete ratio. I need to use law of cosines, because look, I have 35 degrees, I have 43, and I have 19. This is exactly the same scenario, I mean, different numbers, but exactly the same scenario as the last problem. I had two sides and the included angle, and I didn't have a complete ratio. Well, again, I don't have a complete ratio, but what I can look for is I can look for b, okay? So let's go ahead and do that. So I have b squared is equal to a squared plus c squared minus 2ac times the cosine of 35 degrees. Now 35 degrees isn't really all that big, okay? And it's kind of odd the fact that one of these sides is so much longer than the other. And so I'm thinking that angle A is probably going to be obtuse, but let's see. 43 squared plus 19 squared minus 2 times 43 times 19 times cosine of 35 degrees. And we get 871. Now that's b squared. So if we want b, we need to take the square root, and we wind up with b is approximately 29.521. Okay, 29.521. Let's go ahead and store that into b. That's going to be a good idea. Now once I've stored that into b, I now have a complete ratio. Okay, I can use that complete ratio to find a or c. Let's find a. So we're looking for a, so let's go ahead and put that in that first numerator. That goes over 43. Sine of b, I'm using b because that's my full ratio down here, over b, which is 29.521. Now that means that sine of a is 43 sine 35 degrees over 29.521. And I simply need to take the arcsine of that. Let's go ahead and find that ratio. 43 sine 35 over, now I stored that into b, so I can just put b there in the denominator, and I get 0.835. Let's go ahead and take the sine, inverse sine of that, and we're going to get 56. And you're thinking to yourself, that's not right. Okay, 56, 0.664. I thought we said it was going to be obtuse. Well, here's the thing. You're dealing with sine. And sine can be that, or it can be 123. Now the question is, which one is it? Now, this right here is 29, and it's opposite a 35-degree angle. If I decide that it's 56, right, then I have 180 minus 35 minus 56, and that tells me that my angle C is going to be my largest angle, and that can't be the case. It's opposite the smallest side. So it is not 56.664. Now you're probably, oh, sorry, this shouldn't have been out here anyway. It's not going to be 56, it's going to be 123. And now you're getting the idea as to why it's important for us to sort of common sense check our answers when we get down to the bottom. Because if we do, we're more likely to catch mistakes like that. Now, that is going to be the largest angle. It's opposite the largest side. Now, something is going to be, it's going to be small down here. So let's go 180 minus 35 minus, okay, well, let's go up here and grab the 123, and we're left with 21.664. 21.664. And that actually does make sense, right? Smallest angle, smallest side. Middle angle, middle side. Largest angle, largest side. Okay? And all we did in order to find C was say 180 degrees minus A minus B, and we wound up with 21.664 degrees. Okay? So check your answers at the end, because anytime you're dealing with sine, that's part of why I sort of foreshadowed the fact that it was probably going to be obtuse, because I wanted you to recognize that you need to constantly be vigilant with arc sine when you're dealing with these, because arc sine sometimes won't give you the actual angle that you're looking for. It will give you the first quadrant angle, and you'll have to go searching for the obtuse angle that has the same reference angle out in the second quadrant, meaning its supplement. Okay. Now, let's go ahead and move on to another one. Alrighty, again we have side, side, side. And we can, we can go ahead and we can draw it if we wanted to. We don't have to. We can go ahead and say, well, let's look for A first. Well, let's fill in down here. We get 3.2, we get 7.6, we get 6.4. Now, let's go ahead and say 3.2 squared, that's A squared, is equal to B squared plus C squared minus 2B C cosine of A. Now, when you get decimals like this is when I really like to store stuff in, because I just don't like making that many keystrokes. Okay, so 3.2, let's store that bad boy into A. 7.6, let's store that guy into B. And 6.4, let's store that into C. And that means that what we're going to do is we're going to get B squared plus C squared. It's going to be this quantity right here, right? This is B squared plus C squared. Now remember, I'm going to be subtracting that to the other side, so I need let's go with A squared minus that answer, and then I'm going to divide that by -2 times B times C. And what I get is 0.909. Now that's important because that is what is going to be equal to cosine A, 0.909. And if you don't believe me, just go ahead and do the cosine A is equal to 3.2 squared minus 7.6 squared minus 6.4 squared, all of that over -2 times 7.6 times 6.4, and plug that into your calculator, you're going to get the same thing. So we need to take the arc cosine of that ratio, and we get an angle measurement of 24.558. 24.558 degrees. Now, we need to, of course, anytime we get something that small, okay, well, is that reasonable? Yeah, it kind of is. It's by far the smallest. It's half of this measurement, and this one is even larger than that. Let's go ahead and let's use this full A ratio, angle A and side A, in order to find B. So let's go ahead and look for sine of B. We're going to put that over 7.6. And this is going to be sine of A, which in this case is 24.558. All of that over 3.2. Well, that means that I'm going to get sine of B is equal to 7.6 over 3.2 times sine of 24.558 degrees. And b is going to be equal to the arc sine of whatever that ratio is. Let's go ahead and find out what that ratio is. 7.6 divided by 3.2, and then I'm going to multiply that by the sine of, well, let's find the actual value, and let's use it. And that's going to be the ratio, and then I'm going to take the arc sine of that, and I'm left with 80.784 degrees. Okay. Well, all of a sudden, that is 80.784 degrees. Now, if I go ahead and say 180 minus that answer, minus that 24 degrees, I wind up getting 74 for C. Okay, C is equal to 180 degrees minus A minus B, and if I use this value right here instead of looking for its supplement, I'm going to get 74.658. And the question is that reasonable? Okay, because the alternative is to get 180 minus this at 99 degrees, and then if I get it at 99 degrees, I get 180 minus, actually, let's clear that. Let's move up here and just snag that. We're going to get 56, okay? So let's go ahead and take a look at that. The alternative for B is going to be 99.216 degrees, and therefore the alternative for C is going to be 56.226. And the question is, which one is it? Well, there's one way you can actually figure it out. You can recreate the law of cosines. You can recreate the law of cosines for angle B and be really sure about it, because law of cosines is never going to give you that ambiguity. But in both cases here, notice that B is the largest, C is the next, and A is the smallest. Well, what are you going to do at that point? Well, there actually is a way to check it. And I've never actually taught this to my students before, but let's go ahead and see whether it's actually helpful. I'm just as curious as you are how easy it is to use. Malwide's, and it's probably Malvide, because the dude was Germanic, but whatever. It doesn't really matter how you pronounce it. It matters, everything else. So let's go ahead and let's say the formula is side A minus side B over C is equal to the sine of A minus B over 2, so the half angle of A minus B, over cosine of C over 2. Okay, well, let's go ahead and use our first values in black. Okay, and let's see whether we actually get something that's useful. Okay, now let's go ahead. Now A is that 24. Now let's do the left side first. Let's do the left side, and we know that we've stored all these in already, so it's A minus B over C, and we get negative 0.687. Okay, well, it's negative because B was larger, and that's just fine. Let's go ahead and let's do we'll just estimate this because this is us checking our answer, right? Sine of, and let's go ahead and put another ratio in there, A minus B, so 24.6 minus, and let's go with this B value right here, okay? 80.7. Now we're ishing it because we're just checking our answer, so we just need to know whether it's in the same ballpark. And then cosine, and then we're going to take half of this c value. Okay, so that's 74.7. So let's put another ratio down there. 74.7 over 2. And okay, well, let's go ahead and see what the other one looks like when we set it up. We're going to use these red values now. We have sine. Okay, so that's still going to be 24.6 minus 99.2 over 2, and then we're going to close that one off. And then cosine of, and this one's going to be 56.2 over 2. Okay, that one is much closer, right? And so basically, by using Malvai's formula, we have confirmed in a much faster way than recreating cosine. I don't know if it's faster, but it's just as expedient, that these are not the values that I'm looking for. It's these values that make sense. And therefore, it's 99.216 degrees and 56.226 degrees. And that winds up being our solution. Okay? Alrighty. We're going to do some Heron's area formulas here in just at the beginning of the next video. And then I'll probably tack on those two problems that I sort of passed over in the last two lectures, and sort of, it winds up being pretty frustrating, but whatever. It goes to show that that you know, even your teachers wind up making rookie mistakes every once in a while, and that's actually should be somewhat comforting. If you have any questions about what has gone on here in this video, please do shoot me a message on Teams. I will, at some point, be showing you the demonstration for this. It actually uses one of those trig IDs that we did not memorize in 5.5, one of those ones from the right-hand side of the sheet. But seeing as you know that they exist, we'll sort of forge ahead bravely nonetheless. But be on the lookout for video number 3. I have a couple other sort of supplemental videos. I don't know when those are going to go up, but I certainly wanted to get the cosine ones up today. So there you go. Bye.